I would like Avatarland to bring Mr. Bob Ward far, far away from Texas.
Howdy, everyone. Welcome to SQLDay, one of Europe's leading conferences on SQL Server. I'm Bob Ward from Microsoft, and a big howdy from the great state of Texas. So honored that you would ask me to be part of your event and your keynote speaker. I have some favorite memories of SQLDay. Actually, I was there several years ago in person, and two things stood out for me. Number one, I remember when I traveled there, I pronounced the name of the city in Poland, Wrocław, and everyone laughed and said, "What the heck is that?" And I said, "Well, isn't that how you pronounce it?" And they said, "No." And I said, "Well, that's how you pronounce it in Texas." So if you're listening, Wrocław is the pronunciation for that city in Poland, in Texan. Number two is they were having an event the last night I was there, and they asked me, "Hey, we're going to do kind of some fun with the band and so forth. What are one of your favorite songs?" And I said, "Well, I love Leonard Skinner, so how about Sweet Home Alabama?" Little did I know they would perform Sweet Home Alabama on stage for me and put it on YouTube. What a fun tribute. So again, I'm so thankful that you're here today with me. I'm sorry we can't be in person, but at least we're here together to learn about SQL. And I thought today, what better topic to talk about SQL than to learn about SQL Edge to Cloud, all the different assets of SQL that have become an amazing product, anywhere from the IoT Edge to the public cloud. Now, a couple of logistics, the URL you're seeing on your screen right here, this is where the slide deck is. You can pull down this deck already yourself and look through it. There are several links in this deck that will provide great resource for you. I'm going to do some demonstrations, and those resources are going to be at the end of today's presentation. So sit back, relax, and let's talk a little SQL Edge to Cloud. So to start our conversation, let's take a little walk down memory lane and talk about a little of the history of SQL Server. When I joined the company in 1993, I can't believe it was that long ago, and I first started the job, I was presented these, these diskettes to install SQL Server on OS/2. And in the very beginning of SQL Server, this is what we were. We were a desktop type database platform based on Sybase as a database. Now, we separated ourselves, especially when Windows NT came along, to be our own product in SQL Server, but we were still thought more of as a department server. People running small SQL Server workloads on very small servers, pretty much a single, maybe a couple of clients on a network. Remember Novell networks? Competing or connecting to a SQL server in a small department or even like in a doctor's office. Now, SQL 7.0 really started to change the game for us as an enterprise product, both from price and performance. So you look at the evolution of SQL 7.0, 2000, 2005, and even 2008, we became a force in the industry with things like record-breaking benchmarks, known for ease of use, and again, a great price point. You think about in the start of the mid-2000s up to today, we started putting SQL Server in a public cloud as platform as a service. One of the first vendors in the industry to actually put a database as a platform as a service, and today Azure SQL powers all of that. Now, in 2017, we made a radical decision and said, hey, why don't we run SQL Server on Linux? Not because we just thought it was a good idea, because customers wanted that. So now you had an operating system of choice. And then finally, if you think about what's in the SQL Server product today, it's not just an engine, right? A database engine. It's a data platform. It includes things like Polybase and machine learning services, all sorts of rich functionality that are outside the traditional RDBMS platform. But all of that is backed by a proven engine over time developed by Microsoft, empowered by us, but actually you're the ones that actually make this engine go, because of the feedback you've given, the usage you've done, and the popularity you as a community have made it. It's an engine all about security, availability, and performance. So let's take a look at the assets of what I call SQL Edge to Cloud. It all starts with on-premises in your data center. And it actually is interesting because it actually starts in the IoT Edge with a product called Azure SQL Edge. And in today's presentation, we're going to take a look at all these different assets of SQL Edge to Cloud, and we'll talk about Edge in a second. SQL Server 2019, which we launched, I want to say a year ago, because it felt like it was a year ago, but actually it was November of 19, we launched the latest version of SQL Server, which includes rich functionality, crazy things like Spark and big data clusters with the SQL Server, under the proof that it's become a data platform. And then, of course, SQL Server on Linux gives you operating system of choice and opens up new possibilities like containers and Kubernetes. Now, if you kind of think of the public cloud space, we have SQL Server and Azure Virtual Machine, which we call IaaS, Azure SQL Managed Instance, and Azure SQL Database, which is going to include new technologies like elastic pools, hyperscale, and serverless. Now, last year, just recently, we connected these roles by announcing hybrid products, Azure Arc-enabled SQL Server and Azure Arc-enabled SQL Managed Instance, now a way for you to get the power of Azure in your data center, but still running SQL as a product. Now, you may look at all of this, and you may see my presentation today, and you're like, this is too much to handle. I don't even know when to use these things, and I'm worried I have to learn way too much for this. Keep these points in mind. Number one, they're all powered by the same SQL Server engine from a security, performance, and availability perspective. Sure, in some cases, a versionless SQL Server may be more up to date than, say, a certain version of SQL Server, but the same core engine powers them all. Slava Oaks once told me, Bob, the query processor is the query processor, and it's the same query processor engine across everything you see on your screen. Now, if you're a developer, you're worried about what languages are going to work on all of these. Well, guess what? All of these languages you see and more connect an app to any of these assets. And it's actually true that in many cases, your app with no code changes should just reconnect to another SQL asset and work just the same. What about tools? You love Management Studio. Maybe you've used the new Azure Data Studio experience, or maybe you like PowerShell or even SQL Command. Hey, all of those tools connect and work against all of these. And in many cases, these tools are smart enough to adapt and understand which asset they're working to. So for the rest of this presentation, let's take a deeper dive into each one of these SQL assets and take that journey of SQL Edge to the cloud. Well, let's start our journey with Azure SQL Edge. Several years ago, we recognized in the industry that IoT was a thing, and we noticed that developers for edge devices needed to find a way to do data processing at the IoT edge device itself. Companies like 3M were realizing that in their manufacturing plants, they had scenarios where manufacturing devices were in some cases disconnected from networks and not always connected. So they wanted to do things like anomaly detection for their manufacturing devices to help reduce downtime, and they wanted to use machine learning. But how are you going to be able to process data on the device without being connected? So Azure SQL Edge comes along. The ability to take the SQL Server engine and run it in a containerized way on an IoT edge device in a very small footprint so that you can use the power of the SQL engine to process data as the device produces information. So we did things really unique to make this successful. We built into the SQL engine time series data streaming integration with both Kafka and streaming analytics and machine learning. So now you could take a machine learning model based on test data, you could train that model, then you could install the model with the SQL engine in a containerized way, and now you've got a full data processing system where the IoT edge device could be producing telemetry and the SQL Edge database would be processing that on the fly. Then you could take those results and do great things with it to maybe detect anomalies, do alerting, or even send results to the cloud at that point based on things that have been processed by the edge application. So you want to have the ability not to have just time series data streaming and AI built into the SQL engine to T-SQL. You needed a containerized environment. You need to be able to move data to Azure after processing it. But what we knew most importantly is that it wasn't just about Intel processors. We need to do this on ARM processors. And the SQL engine was compiled for Intel. So we found a very clever way based on our research and work on SQL on Linux to make Azure SQL Edge run on ARM devices, which is a very popular platform along with Intel for IoT edge devices. Now, the SQL engine comes with great performance and security already built in, which is a great factor for us because developers needed that. For example, column store indexes work as is in the SQL engine. And consider this, if you're building SQL Edge applications, it's the same SQL engine, so you can build these edge applications outside of the IoT edge device, test them, make them work well, and then deploy them wherever you need them, especially in the IoT edge. Let me take an example for a second and show you an example of how you may be able to do this. Now, this is a repository on GitHub and a repro that we've built. You can see here the location where this is, and it's based on a wind turbine demo. And what do we mean by this is that a fictional company has a wind turbine farm where they may not be connected all the time. But what they would like to be able to do, the company that owns the farm, is get alerts based on wind turbulence that might cause issues with these wind turbines. And the wind turbines themselves can measure wind turbulence. So wouldn't it be great if you could do data processing and use machine learning models to do better prediction of when issues would occur? So this entire GitHub repo gives you all the code to run this. And here's what you're going to love. You can do all of this in Azure. We have a way of deploying an IoT Edge SQL Edge application inside a Linux VM with containers. So you can get used to the processing of how to go do IoT Edge development. And then when you're ready, take that and deploy that entire application and model down to, say, a wind turbine farm. So that's Azure SQL Edge, the first leg of this journey. Again, it's a very small footprint, less than 500 megabytes. It's the SQL Server engine, as you know and love, but well integrated with time series streaming, including Kafka and Stream Analytics and machine learning. Okay, let's move over to the next part of our SQL Edge to Cloud story and talk about SQL Server 2019, how it solves modern data challenges. And here's what I mean by that. We introduced in SQL 19 an extension of what we had before with Polybase so that you can query any of the icons I show right here in this screen with no data movement. And not only that, with a big data cluster, we'll include in a Kubernetes cluster the ability to have Hadoop and Spark integrated with SQL Server and all these icons. So you can build, quite frankly, an entire on-premises data lake solution all connected through SQL Server or connected through your favorite Spark endpoint. So data virtualization and big data clusters are a big part of why SQL 19 solves modern data challenges. But notice all about the new platforms we support. I've talked about some of these already. Imagine you backing up a database on any one of these icons and restoring them to any one of these icons because the SQL engine is the same across all of these platforms. It opens up new possibilities for you in what you want to do with SQL 19. And then part of our data platform story is machine learning. We talked about how that powers Azure SQL Edge. Well, with SQL 19, we took the capabilities of doing R and Python and added Java to the solution in a secure and isolated way to do built-in machine learning and extensibility. You look across this top row, and it doesn't even feel like SQL Server does it. It's all about this other technologies that are not part of the core engine. But we always want to make sure we iterate on the core engine. And on the bottom left here, you see the fact that intelligent query processing, which is all about getting faster with no code changes by simply going to a new database compatibility level, is part of SQL 19, part of Azure SQL, also part of SQL 19. For security, we extended always encrypted by adding secure enclave capability, and we added new capabilities for data classifications to help you tag and label columns and audit access to those columns to maybe help with you to meet things like GDPR compliance. And finally, in the area of availability, we added this amazing technology called accelerated database recovery, which we'll talk about a little more in a second. But notice the customer logo, Bank Itaú, one of the largest banks in South America. They were able to upgrade to SQL 19 in their test environment, go to the latest compatibility level, and achieve a 92% increase in performance with no code changes. Because they turned on accelerated database recovery, they greatly reduced the downtime they were seeing sometimes in their applications, especially during failover scenarios. Let's spend a little bit more time talking about accelerated database recovery. But let's do it with a fun story. I'm going to pick on some of my colleagues here. Imagine Buck Woody comes along and he tries to open a transaction and delete a billion rows. Well, this is going to cause a lot of blocking problems in the business and even downtime. So Anna Hoffman comes along and she tries to go help Buck out by killing Buck's session. I'm sure she wants to strangle Buck, but she kills her session and Buck's session goes into a rollback state. And here we are, we're still blocked. Now, Pedro Lopes, you may all know Pedro Lopes in the industry and our community, a colleague of mine, is a very smart person. He thinks the way to solve this is to crash SQL Server and it'll just come back up and run with no problem. Well, this entire time, Pamela Hood, I know one of my great colleagues, she's monitoring the transaction log and it's growing out of control because it can't be truncated. This is a problem. So they call me, Bob Ward, I used to be a supporter, right? They're like, Bob, what is going on here? Anna tried to kill Buck's session and it went to rollback state and we're still blocked. Pedro tried to crash SQL Server and it's stuck in this percentage mode where it won't recover. What do we do? And I'm like, you got to wait till it finishes. And they're like, Bob, what's the answer so we don't have this problem again? And it's accelerated database recovery. It sounds too good to be true. It's all based on a persistent version store. You enable it as a database option. It's on by default in the cloud. It's independent of locking isolation levels, so we still maintain those no matter if we're using this or not. Rollback becomes faster than you can snap your finger. Undo recovery happens so fast, you don't even print a percentage in the error log. And guess what? Your transaction log is no longer, the truncation of it is not tied to active transactions. Well, you have a lot of questions, I'm sure, like, is it going to be cost me performance problems or take up more space, or will I still see versions in TempDB, and does it work with AGs? So here's great news for you. We have a white paper written by the actual developers that built this version, this specific feature of ADR, which you can read. You can look at the deck and click the link. It's also called Constant Time Recovery. This paper gives you all the details and answers all of these questions for you. But how much do we believe in this technology? It powers Azure SQL SLAs. We need accelerated database recovery. So it's even on by default. You can't even turn it off. On Azure SQL database, on a managed instance, especially scenarios like hyperscale, we need ADR to make sure that active transactions do not affect your service level agreement. All right, now let's look at a demonstration of SQL Server 2019. Specifically, let's see accelerated database recovery in action. And just a reminder that you'll have resources at the end of this presentation where you can get all the demonstrations I'm showing you here today. What you're seeing in front of you is Azure Data Studio. This is our new tool, cross-platform. It's actually not that new, it's been around for a while, but it's a really interesting tool because it provides a concept called a SQL notebook, which I love to show in demonstrations. First of all, if you look over here on your left-hand side, you'll see here kind of an object explorer experience. In this particular case, it's a folder of files. This is pointing to the SQL 19 workshop I mentioned. And you can see in here in the availability module, we have demonstrations of accelerated database recovery. So you can go run these yourself through our GitHub repo. Again, resources available to you at the end of today's session. So let's look at the notebook. What is a notebook? Well, in this case for SQL, it's a combination of markdown text and T-SQL code. This is the markdown text itself, which I can get very creative to give you descriptions of what I'm going to show you. And then you have something called a cell. A cell is a unit of SQL code you can run. Another thing I love about SQL notebooks is that the results are saved into the file. So you can go run a demonstration or show a demonstration with actually really running the code. You can run it in an environment and then show the results later. That's what I'm going to do here. I have a simple database, and I don't know if you remember when I came to Poland before, but I'm a big sports fan. So this is the Dallas Cowboys, my favorite NFL football team that I use. You know, when you get to do demos, you get to pick your own names. So in this database, I have a table, a very simple table with 100,000 rows in it. I'm just going to go insert 100,000 rows, and then I'm going to go look at accelerated database recovery in action. So if I scroll down further in my table here, notice what I'm going to do is I'm going to turn off this functionality. It's not on by default in SQL 19. It is in Azure. So I'm going to turn this off here to show you the differences with ADR off and on. Now, what I'm going to do is I'm going to do exactly what I told you Buck Woody did, except I have a smaller number of rows. I'm going to go start a transaction and delete all the rows in the table. And I expect that when this is finished, it takes about 5 seconds. Now I've got an active transaction where I'm blocking the world from getting access to this table. This could be downtime for your app and your business. So first of all, let's look at the transaction log. Now, I'm using simple recovery here, so I expect that checkpoints would help me truncate the log. But in this particular case, just by default alone, I can see I've used almost all my log space because I've got that active transaction. And even when I try to checkpoint the database, I still have almost 80% of the log that's used. Again, have an active transaction, even though it's simple recovery. Now, what's interesting is the rollback part. Let's say we killed the session or explicitly roll back the transaction. Notice here, it takes 11 seconds to do that. Now, with large row sets or larger tables, this could take significantly longer. What's taking up this 11 seconds? This is Aries recovery algorithms for by default without ADR. So we're having to build what's called compensation records in the transaction log so that this can be properly undone if undo recovery had to run. We can simply go and take the deletes and apply inserts to make sure the data is back at the state before the transaction because it never got committed. So at this point, let me scroll down and show you what does it look like with the same scenario when I turn on accelerated database recovery. Here, I'm going to turn it on. I'm going to run the same demonstration. I'm going to come along. I'm going to delete my rows again. And then I'm going to look at log space before and after a checkpoint. Now, this is really interesting. Notice here, just even by default, I only have about 20% of the log used. And after a checkpoint, which could have been an automatic checkpoint, I'm at 7% used. Even though the transaction's active, because I'm using versioning, I can truncate the log safely. I don't have to worry about those log records because I have versions stored in the database. Now, you may be interested, like, how fast is rollback? And so I'll just slowly scroll my screen here, and I'll stop and ask you at home, wherever you are around the world watching this, how fast do you think that takes? A lot of people have told me, Bob, probably a second. It took 11 seconds. Oh, it's a second. It's a half a second. It's 100 milliseconds. Look at this. It's less than a millisecond. Isn't that crazy? Rollback happens like this. That's because with ADR, all we need to do is mark the transaction aborted in the transaction log, mark the versions aborted in the rows, and we're done. There's not a lot of extra effort there. Because we're using versioning, we can do this. Now, in the workshops, if you want to go look at other examples, I show you an example of crashing SQL Server and seeing undo recovery happen very fast. Without ADR, it takes several minutes to run undo recovery. You see the progress of messages in the error log, but with ADR on, undo recovery happens so fast that there is no messages in the error log. So great demonstration, and it just shows you how powerful this can be in your environment. You really need this when you need it. So consider in your environment with SQL 19, turning this on, experimenting to make sure it works with your application, and just imagine the pain you no longer have to suffer because of this feature being on. So that's a demonstration of accelerated database recovery in SQL Server 2019 and on by default in Azure SQL. We've talked Azure SQL Edge. We've talked SQL Server 2019, which includes both Windows and Linux. Now let's talk SQL containers, kind of a special way of running SQL Server in your on-premises environment. A lot of people don't understand exactly how containers work, so let's talk a little bit of a perspective of why SQL containers make sense for you. You, let's say today, maintain a shared SQL server for developers, and it's always getting changed and messed up, and it's really causing a lot of frustration. Use containers now. Containers are a consistent image. They're portable across any operating system you choose, or any cloud or any environment, whether it be Windows, Linux, or Mac. So now think of taking a SQL Server image that's consistent and giving it to your developers, and they run that consistent image locally with a database on their own machine versus having to have this shared development server. Hey, just go search for SQL Mac Challenge with a blog post written by myself, and you'll see what I'm talking about. Now, containers are more lightweight because they complement VMs. Containers don't replace virtual machines, they complement virtual machines. Because they're an isolated process, that's really what they are, an isolated process. All that's necessary to run the container image are the necessary binary and libraries that program needs, like SQL Server. So I can pack a lot more SQL instances in a VM than I could before. In fact, on SQL and Linux, that is the way to do multi-instance SQL servers with containers. Now, containers provide this consistent image. Consider the scenario where you want all your developers to use a certain cumulative update of SQL Server combined with a set of SQL scripts and tools, and you want it to all be the same. You could build a custom image that is consistent and give it to all your developers and let them use that in a local environment. And now you've got this consistency that you did not have before. In fact, if you look at the bottom of the screen, containers light up DevOps environments. I've got a nice video you can watch from last year's Build conference where I show the combination of using declarative changes in GitHub with SQL containers powering a complete DevOps lifecycle. Containers are more efficient from a couple of perspectives. One is containers are pre-installed versions of SQL Server. So when you pull a container image and run it, within seconds, SQL is up and running, no install required. And there's really no patching of a container image. In fact, what you really do is you switch containers to patch SQL Server. That's because cumulative updates are compatible between each other. Notice in the diagram here on the right, I've got a VM running 3 containers, all supported by a container runtime. Remember, containers interact with the host operating system. They don't go through a runtime as an abstraction layer. They directly talk to the host OS. In fact, they're just native processes running in that virtual environment. But let's say the database is in something called persistent storage, system databases and user databases. If I want to update a cumulative update, I simply stop one container. I start a new one with pointing with the SQL Server of the new CU image. Each SQL container is specific to a cumulative update. I point that to the persistent storage databases. I start my container, and within less than a minute, I'm up and running now, and I've patched SQL Server without really truly patching it. And the really cool story is that if I don't really like how that's behaving, I can roll back to the previous cumulative update by stopping the new container, and then starting the old one. So there's no patching required. That's a great story. And you can see here that we now have Active Directory support, which is something we did not have in the past. DV01, one of the original pioneers of SQL Server on Linux, actually uses containerization on Ubuntu to support a whole bunch of developers who used to be Postgres developers, and now they achieve unparalleled performance and scalability running SQL containers in their environment. So we've covered everything from the edge to SQL 19 to Linux and containers, which runs on your on-premises environment. Now it's time to shift gears and talk about SQL running in the public cloud, specifically something we call Azure SQL. Okay, let's shift gears and talk about public cloud with Azure SQL. Azure SQL is a branding. It's a portfolio of Azure services. So let's talk about what it is. Let's go into some unique aspects of Azure SQL that are both the same and different than SQL Server, and see a demonstration. So it all starts with SQL Server and Azure Virtual Machine, which is considered infrastructure as a service. And that is because it's a complete SQL Server in a VM, just like VMware or Hyper-V for you today. You have complete access inside the VM to all the SQL software, to the operating software, but we provide the infrastructure. We give you storage resources, we give you networking resources. We even give you the ability to deploy a SQL Server from what's called the marketplace, pre-installed versions of combinations of SQL Server and operating systems. Now, people choose this option because it's the fastest way to get in the cloud. You can literally lift and shift your entire VM with SQL right into Azure using this option, but it has the least managed capabilities. Now, we want you to feel comfortable running in Azure, so we are going to give you some extra capabilities that are considered managed. If you register your SQL Server with us, we'll give you licensing edition flexibility. We'll give you automated backups, automated security, and even a unique, consistent portfolio inventory of your Azure SQL resources. But again, this is for complete SQL Server and operating system access. Now, as you go from left to right, you think of platform as a service. And so Project Cloud Lifter evolved into a service called Azure SQL Managed Instance. Think of this as a complete SQL Server instance, but it's a platform as a service, so you don't worry about the operating system or the VM. In fact, you don't even know how we deploy this in the background. Your interface is a SQL instance. These are for scenarios where you need a complete SQL Server surface instance capability, the power of SQL Server with the best of platform as a service as a cloud. You're going to get managed capabilities like built-in availability, all sorts of great functionality, easy deployment. It's all powered by Azure, and even native virtual network support. But that's Azure SQL Managed Instance. Again, think left to right for more control, right less control, but more managed capability. And the final piece of the puzzle for Azure SQL is Azure SQL Database. Think of this as a contained database. This is best for cloud-born new applications. For the other two options, these are really the migration paths that are best for SQL Server users. The quickest is SQL Server and Azure VM, Azure SQL Managed Instance being the next, giving you the most platform capabilities, and Azure SQL Database giving you the most platforms and service capabilities, but it is just a database. And so your access to this is not going to contain instance-level features. Managed Instance is going to include things like agent and replication, things that are more instance-level capabilities, while Azure SQL Database is going to be more just like a database, but we're going to open up new possibilities with things like serverless and hyperscale. Now, Allscripts is a company that took advantage of what we had in Azure SQL to get very quickly to the cloud. And what they did is they used the capability of Azure Migrate to lift and shift hundreds of virtual machines running SQL Server very quickly in the cloud, as is. So it didn't matter what version of SQL or the operating system they're running. They could literally just move the VHD snapshots into the cloud, make some optimizations, and then we're up and running with their SQL servers. Let's take a second now and dive into more capabilities of why Azure SQL is unique, more from the platform as a service side of the house. So we have a concept with Azure SQL Database and Managed Instance called service tiers. These are choices you're going to make to unlock capabilities and resources. The first choice is something called general purpose. And again, per its name, this is going to be for most business workloads. We're going to store your database and files in Azure storage. We're going to give you reasonable IOPS for performance. It's going to be the most cost-effective, and we're going to open up new possibilities where things called serverless, where you can do auto scaling and only pay for the compute you need. And you only get one primary replica. You need to think of this almost like a failover cluster instance. So you do have built-in availability, built-in backups, but it is shared storage. So this isn't a replica design, again, like a failover cluster instance. It is applicable to many workloads, which is why it's called general purpose. Now you shift over something called business critical. These, per its name, are meant for more enterprise type applications that need low latency for I/O, very fast recovery, and even a readable secondary. So in this case, we're going to put your databases on local storage. But what we're going to do behind the scenes is we're going to do an availability group. I'll show you more of that architecture in a second. You're going to get faster I/O performance, but you're going to pay more for it. And you're going to open up new capabilities like in-memory OLTP. And then because we're using a replica design, you do get a free read replica. Now, these two service tiers are applicable for Azure SQL Database and Managed Instance. And you can choose and go back and forth between them. You can actually migrate and make choices, without any migration, of which service tier you want, along with the different choices you get for things like vCore and storage. Azure SQL Database has one unique service tier option that's called Hyperscale. This is only available in Azure SQL Database today, and it's a one-time move. You cannot migrate back to general purpose or business critical or make that change if you need to. So you think carefully if you need Hyperscale. But it uses a unique cached service tiered architecture, which is why it uses a combination of local and remote storage in a series of caches. Your I/O performance are somewhere in between general purpose and business critical. So is the cost, but here are the differentiators. Almost unlimited storage, where database sizes may be constrained to terabytes of storage in the other two options. Hyperscale has almost unlimited storage. And we do that and achieve that by using this cached system. It also opened up new capabilities like multiple read replicas. You can choose 0 to 4 read replicas, which is why Hyperscale can be a great benefit for customers that need that read scale capability. Now, an example of a customer that successfully used our past services is HR Block. It's an interesting customer. Maybe you've heard of them before. They were able to go to things like Azure Virtual Machine, but then also make that leap to Azure SQL Managed Instance. Azure SQL Managed Instance provided that surface level capabilities, that compatibility that's with SQL Server. So while they made some journey into virtual machines, they were also able to make that move into PaaS Managed Instance because they needed a full SQL Server, but they wanted the built-in capabilities of things like business critical to run their business and save themselves costs of how to maintain their SQL servers. Now, I mentioned that general purpose service tiers have built-in high availability, almost like a failover cluster instance. Let's look at the unique architecture of a business critical service tier. So here's what's interesting. When you deploy a business critical service tier, you just declaratively say that's what you want. I want an Azure SQL database or managed instance as business critical. And behind the scenes, we are going to deploy an availability group for you with no configuration on your part. If you look at this diagram, what you're going to have here is a primary replica your applications are going to connect to. And on that replica, on the local drive, is where we're going to put your database and log files. Now, notice here's something called a control ring with gateway servers. The application is going to connect to the gateways to know where to connect to your primary replica. That's going to become important when it comes in terms of failovers. So you don't have to deploy any kind of listener technology. We do that automatically for you. Now, when you deploy business critical behind the scenes, we are going to automatically deploy 3 secondary replicas, and we always try to keep 4 replicas available at all time within the business critical tier for your database or instance deployment. The backup files go to a different Azure storage location. So right away, you can see we've deployed best practices to make sure that your backups are in a different location in your databases. By default, these backups are geo-redundant. In other words, they're redundant across regions. You can choose to make that locally redundant if you want for sovereignty reasons. But the fact is, your backups are automatically redundant, and so are your databases. Now, just like an availability group, we're going to want to make sure one of these secondaries stays in sync when commits occur so that we can do a failover. Now, if we have to do a failover, we're going to use Service Fabric integrated with the SQL engine to make decisions should we do that failover. But because we're using availability groups, just like you would have in SQL Server, and redos are always being applied, recovery time is very fast. And don't forget, always on availability groups are working in this environment, so that failure is even faster than maybe you would be used to. Now, you're probably wondering, like, how does your application connect to the new primary replica should it need to? Well, because we're using this gateway design, it's an automatic built-in listener Therefore, you don't make any changes. You just do a retry in your application. You're automatically redirected to the correct primary replica. And then for free, with no additional charge, you get a single read replica from one of these replica designs. Now, you can go even further here. For free, as part of your description, you can go further with something called zone redundancy. This is where we're going to get the maximum SLA from us in a business critical tier, where we're going to take the secondary replicas and we're going to put them in different data centers or availability zones. And we'll automatically put a traffic manager that you don't even know is going behind the scenes to route you to the proper secondary should a failover occur. So you get great built-in HADR from business critical. The backups are in separate storage. The backups are automatic for you. You get a read replica. We've already configured AGs. You don't have to even worry about that. And then by not paying even extra money, just as part of your subscription and using business critical, you get a read scale replica and you get zone redundancy choices to even go further with your availability. So to me, this is one of the true hero stories of platform as a service, especially when it comes to business critical service tier choices, which exist both for managed instance and Azure database. Now we mentioned hyperscale, and hyperscale has a different architecture that's quite unique. It's an architecture we're going to build to allow you to get unlimited storage databases at scale. And here's kind of how it works. So first of all, you do have a replica just like you do with business critical or general purpose. And you do have a gateway that's going to point you to the proper nodes. But this primary replica is different in the sense that it's a SQL server with a buffer pool, but it also includes something called an RBPX data cache, which is effectively kind of like a buffer pool extension, except better, using local SSD drives. So even though you have huge databases, we hope that a lot of your data comes from either the buffer pool or from this local cache. Now, it could be that the data doesn't come from those. So where would it come from? Well, we create a set of page servers, which are SQL servers that contain pages. And these pages have a buffer pool and a cache as well. So if you can't get the data from the primary node, then you can go perhaps to a page server, which is built to align with each file that we have for your database. And then finally, the databases themselves are stored in Azure Standard Storage. Now you're thinking to yourself, well, that's not very fast, Azure Standard Storage. But remember, the data files shouldn't be accessed very often because most of your data should come from either the page servers or from the caches or buffer pool from your primary node. Pretty cool technology. And one of the reasons why data files in Azure Standard Storage is important is we can use snapshots to back up the databases, which make point-in-time restore extremely fast. The one thing missing from this diagram is the transaction log. Well, how does that work? Well, in SQL Server, we had already architected the engine so that the transaction log can be in a remote location. In this particular case, the landing zone is where the transaction log exists, not on the primary node, and that's on Azure Premium Storage. We age that out to Azure Standard Storage to support point-in-time restore operations. But even more important, we have a separate node called the log service, which will look at the landing zone, use its own log cache to feed changes to both page servers or to secondary replicas. And if a failover needs to occur, it's just like it occurred in the case of Business Critical, where the service fabric is integrated with SQL to fail over to one of these replicas. Now, when I first built this diagram, my colleague Anna Hoffman said, like, Bob, I think this is a mistake. 0 replicas wouldn't make sense here because you couldn't fail over. Remember that this is kind of like the best of general purpose with Business Critical. The data files are in Azure storage. Therefore, if I didn't have any replicas, I could still fail over to a new primary replica that's pointing to a set of new page servers from Azure Files. But if I add replicas, I'm going to have faster recovery time because of the existence of these replicas in which we're always applying log changes. So it's a pretty interesting design. It's a tiered architecture using caches, using Azure storage. This is how we're able to provide huge amounts of storage for you and great scalability. In fact, a customer of ours, ClearSale, that does fraud detection, this is what they needed. They needed data of very large data sets to support a huge transaction rate to help folks do fraud detection. But at the same time, they needed that read scale capability. So imagine a world where you can even add replicas to scale your app. My colleague Anna Hoffman has demonstrated this, where we only had one replica. She just added replicas on the fly to an app that was connecting in to the read intent part, and it just scaled automatically in a dynamic fashion. Hyperscale, a great story, and one of the great true innovations available in Azure SQL database. Besides built-in availability, I thought I'd briefly mention there are other values of being in Azure in the cloud with Azure SQL. One of those is called Azure Defender, the ability to give you vulnerability assessments and advanced threat protection for things like SQL injections to protect your data assets for Azure SQL. We have a new functionality we just announced called SQL Insights, where we're going to integrate with the Azure Monitor ecosystem to give you that Perfmon-like feel across all of Azure SQL assets that you have. And then finally, everybody wants to get faster without making a lot of changes. So intelligent performance is going to include functionality like automatic tuning. We can recommend and even create automatically and drop indexes for your Azure SQL database application. Okay, let's see to the demo. Let's see some of the value-added services that Azure brings to your SQL resources in the cloud. Okay, we mentioned Azure Defender as one of the value adds of being in the cloud. And you notice here in my Azure subscription, Azure Defender has all sorts of different coverage across all different Azure resources. Specifically for Azure SQL, you can see here there are security alerts that might affect my Azure SQL deployments or vulnerability assessments. Let's look at vulnerability assessments for a second. This is us applying best practices based on known recognized benchmarks like FedRAMP and CIS, and applying those rules, which, by the way, you see here, we can update these rules dynamically and rescan your assets, and giving you suggestions of possible things you should take action on that are based on the configuration deployment of your Azure SQL assets. Now, what I love about this functionality is that it's across all my Azure SQL assets. It gives me a priority and a severity look at the findings. It allows me to rescan at any time. Rules are updated dynamically as we see new rules that might apply. And then as you drill into these rules, you can see how we apply the rule. Like, do we run a SQL query to detect the problem? You can even set baselines. So you can decide for any kind of given vulnerability assessment rule that we find that that rule is actually okay for your deployment, and you don't want that to be flagged again as a possible problem. Then you can actually turn that off at any point in time if you'd like to do that. So vulnerability assessments are really nice. In fact, you can see some examples down here below what some of these look like. And a lot of them have to do with security authentication settings or even surface area settings. And you can see severity or how many different databases or instances it applies to, and what kind of benchmark did we use as a rule to go do the vulnerability assessment. So that's one part of Azure Defender. Another is what we call security alerts or advanced threat protection. And a good example of that might be a SQL injection attack. So imagine a scenario where an application is written in such a way that the text that is supplied sometimes with fields that may be some sort of criteria for a query are not actively checked correctly. Well, intruders sometimes take advantage of that and try to inject strings into these fields where the application might perform a dynamic SQL query that could cause an injection problem. We can detect those patterns, and you can see an example here against one of my databases. This was detected. I can see here, where did it come from? What was the application name? And I actually can get information about the string of the actual query that was sent to the SQL server that could have caused that. I can find all sorts of information about where it came from. I can even find remediation steps that I should take action on to prevent this from happening further. What you'll love about Azure Defender is that we started with Azure SQL Database, but now we use Azure Defender, and it's possible for you to subscribe to that to run vulnerability assessments and advanced threat protection with SQL injection detection and other types of detection. And you can run that across Azure SQL Managed Instance, even SQL Server and Azure VM, and we're starting to push that down even to on-premise environments with SQL Server as well. So check that out. Azure Defender is something you subscribe to add to your Azure subscription, but it's well worth your time to take a look because we do use machine learning algorithms in many cases to try to detect these known security patterns. So that's Azure Defender. Another area where we said we invested for value in the cloud is performance and monitoring. So we'll look here at our new experience for SQL Insights for Azure Monitor. Now in my subscription right here, I've got set up monitoring. And what you do is you kind of configure a separate virtual machine to run our monitoring software through Telegraph, an open source known software. And we document in the Telegraph GitHub repos all the queries we use. Set up this virtual machine. It's going to produce log analytics data. This is really beneficial to you because you can customize then your view of this data, or you can consume this as a partner or as an ISV or even as a developer. Now, SQL Insights is really nice because any SQL that you have in the cloud, it can connect to. So for example, I can go across a bunch of Azure SQL databases, which is quite nice. So I can start looking at information across databases. And notice here, it even supports the ability to look at secondaries that have been automatically configured for, say, like a business critical service tier. So if I wanted to look at information across databases, I can easily do that, which is really nice. I can look at activities, I can look at space, all sorts of information at a level that exists across different database deployments I've made. Now you can see here, I'm looking at transactions per second or batch request across all different types of databases, which is really nice. Or I can drill into specific databases. Now going back and looking at monitoring again, notice this supports Azure SQL Managed Instance, or even a SQL server in an Azure virtual machine, separate SQL instances and several machines, and even an availability group. If I've got set up an availability group, I can point insights to look at read replicas in an availability group. Okay, let's look at a specific database example, not just across databases. And again, this feels like Perfmon to you, right? CPU, memory, IO, the basics. And then you want to go get more key statistics about things like processes being blocked or space usage, and even weight categories and specific weight types. That's quite nice. As you go across the list of these visualizations, now you're going to drill into things like, what are my transactions per second, batch requests per second. Of course, that's needed to look at throughput a lot. Even clerks to find out what the highest memory consumers are in your database. A really nice view of data and log file usage. And even transaction throughput information, including things affecting write log IO, and then even database IO. We want to look at latencies across your database and log. And then this last feature is really nice. This is really going to feel like a Perfmon, where you can go see almost every counter you can dream of that applies to your Azure SQL deployment. Now, again, this is just a visualization that we provide by default, but SQL Insights is running in a virtual machine with Telegraph, feeding a log analytics workspace. So you can go in and create your own workbook and consume any one of the metrics that we're producing. So that's SQL Insights involved in preview today, works across Azure SQL Database, Managed Instance, SQL Server and Azure VM, works on primaries, even works on secondaries. Now, the final thing I wanted to show you was automatic tuning. Automatic tuning being a functionality that's built into Azure SQL Database, no extra fees required, no extra subscription required. It just comes with Azure SQL Database. You're looking at a database where Query Performance Insights is a visualization across the query store, which is on by default in Azure SQL Database. So I can go and look at my top resource consuming queries by CPU or duration. Even can see their execution counts, and I can see a visualization over time on the usage, or in this particular case, the CPU usage that they're consuming. Now, because of the fact that we have the ability to monitor performance information about your database, not your data, looking at things like the query store, we can give you recommendations for Azure Database. You see here that you've got a warning that there are some recommendations. Now, in this case, these recommendations often come in terms of indexes. So we're able to apply machine learning algorithms against query store over time and give you recommendations on indexes that should be created and dropped based on possible impacts they may make to your application. You can even see a history of indexes that were applied. And if you like the recommendations that we give you, you can automate this. You can automate it at the Azure level, the logical server level, or at the database level. The forced plan option, which is automatic plan correction, is on by default, but you can come in and turn on create and drop index. So if you trust our recommendations, let's say you're a brand new developer and you want to run against Azure SQL Database, you could turn this on and have us automatically apply indexes for you. We don't just do it a one-time thing. We monitor the indexes we've applied over time and can drop ones if we think it's caused worse performance for you. Now, if you start using this technology and just throw one query at it, we're not going to do that. We're going to look at workloads over time and use machine learning algorithms to decide what are the real true patterns where a query performance over time with, say, things like high execution counts may really impact your workload to apply those indexes. So great examples here of value in the cloud. We've seen Azure Defender, we've seen SQL Insights with Azure Monitor, and we've seen automatic tuning using the power of Query Store and the power of the cloud to do things like automatic indexing. So one final comment I want to make about Azure SQL is cloud migration. We have many customers today that love running SQL Server on on-premises environment, but they're looking to move some of their assets of SQL to the cloud. So first of all, on this slide right here at the upper right-hand corner, note this website, ak.ms data migration. This is a one-stop shop for you for all your information about migrating SQL Server to Azure SQL. But there's a few things that we've been working on that I think you'll find interesting. Number one, we announced at Ignite a new preview experience for Azure Migrate to discover and assess your SQL Server assets, where you can go scan thousands of SQL instances and get information about suggestions for us about what is the right Azure SQL deployment that may best suit your needs, whether that be a SQL Server and VM, managed instance, or Azure SQL Database, even giving you cost information at projected costs of running SQL Server in the cloud. In addition, we are currently working on preview for a new inline migration experience with Azure Data Studio. Imagine pointing Azure Data Studio to an existing SQL Server and being able to migrate that inline directly to Azure SQL Managed Instance. And then finally, database migration service has been a great service to do migrations from SQL Server to the cloud, but we have a new preview log replay service that we just announced, where you can do a very simple way using PowerShell to migrate online a SQL Server into an Azure Managed Instance. This is actually a really powerful way if you've got SQL Server and Azure VM today, where your backups are in Azure Storage, a very common technique for people to do. You can use the log replay service to take advantage of those backups and do an online migration using log shipping technology to Azure SQL Managed Instance. So the last technology to mention today about SQL Edge to Cloud is Azure Arc-enabled data services. Ford is an example of a company that would love to get the power of Azure with their on-premises assets. They don't want to necessarily move their data and assets to the Azure SQL public cloud, but can't they get the power of Azure in their environment? And that's what Azure Arc-enabled data service is all about, featuring Azure SQL Managed Instance with Azure Arc. So in a disconnected or connected way, you're going to be able to run SQL in Kubernetes as a set of containers, but get the feel of a managed service and be connected to Azure. So that, for example, you can see inventory of all Azure SQL assets, now including Azure Arc Managed Instance, and also including the ability to upload metrics and billing information, that type of thing. Azure Arc, SQL Managed Instance, PostgreSQL or Hyperscale, part of the Azure Arc-enabled data services family, are available today in preview. That is one of the powerful stories for our hybrid play to combine now SQL in a hybrid fashion with Azure Arc. Now, we talked a lot of different options for SQL Edge to Cloud. There are a lot of different options. SQL's everywhere you need it. So when do you really know what to use in what scenario? I put this simple table together for you. When you get the presentation deck after today's talk, you can go look at it and decide for yourself whether this might help you make some decisions on what SQL option is best to me for what scenario. Think about where we've come today. Started for this diskette story, right, back in the 90s when Bob Ward started with SQL OS2. And SQL has now become a force in the industry as a complete data platform. Again, SQL is everywhere you need it, whether it be on the IoT Edge with Azure SQL Edge, whether it be SQL Server 2019, the latest version of SQL Server that is modern, available for you on Windows and Linux, or maybe it's a Linux container you need for those great DevOps scenarios or containerized application scenarios, or it could be the public cloud. Again, you're thinking about moving some of your assets to Azure SQL. Why not take advantage of built-in capabilities? Lift and shift quickly into Azure VM, or go to platform as a service and get the value of the cloud with built-in HADR, Azure Defender, SQL Insights, automatic tuning indexes, all those built-in capabilities to make your job easier and more productive. But you could be looking at hybrid. Maybe you want the power of Azure in your environment. So Azure Arc, currently in preview, may be something that you want to take a look at. Now, that's a lot of information. You probably want to know, where can I learn more? Because there was a lot covered in a single hour, but I got to dive deeper. We've got the resources for you, including some you see right here. Let me call out a couple. If you look at ak.ms SQL workshops, this is the one-stop shop of a complete GitHub repository of all of the training that the Azure SQL and SQL Server engineering teams have built, including free labs, free training for you to pull down, fork it, use it at your own need. It's all free. You might be wanting to learn Azure SQL, but you really don't want to pay for Azure SQL resources to do it. I've got you covered. you can go to our Microsoft learning path called Azure SQL Fundamentals. Anna Hoffman and I built this. You're going to get a really good comparison of SQL Server with Azure SQL and be able to go through our exercises and labs and get a hands-on perspective of Azure SQL without paying for any money to do it. It's all for free. Now, you want to follow probably the latest news of everything we're doing in the SQL space. So following the @AzureSQL Twitter handle is a great way to do that. Or maybe you're a video person, you like catching up on videos, very small video feeds about things going on in Azure SQL. Take a look at our YouTube channel. I got our YouTube resource listed here. This includes our show Data Exposed, hosted by Anna Hoffman. This is a great way to keep up with the latest innovations. You'll see all sorts of people like myself and other members of the engineering team or the community show up and talk about SQL Server and Azure SQL. Or maybe you're a book reader. Look at these books you have available to you to learn SQL Linux, SQL 19, or new information about Azure SQL. We've got all the resources you need, and it's our job and our mission to empower you. We're open source preventers. Everything we provide to you that you see here as resources are available to you, free to use. You think about the community today, the community is Microsoft empowered, but run and driven by you. You're the engine that makes SQL Server and Azure SQL go. Thank you all so much for attending today's keynote and for attending the SQLDay conference. Again, one of the best conferences in Europe for SQL Server. I wish I was there in person with you, and I hope in the future to be there again someday in person. Hey, a couple things to call out for you. Here's some resources you have for where to get this deck, how to follow me on social media for things I post about Azure SQL, and I'd be remiss if I didn't call out the data community. Buck Woody and Ree Irish and my team have spent a lot of time behind the scenes setting up and empowering you, but you're the one now driving it. Look at this link for the Azure Data Community, all the resources you need to know about local organizations across the world, all spreading the word about Azure SQL, spreading the knowledge about SQL Server and Azure SQL. Hope enjoy the rest of the conference. You might see me again show up at another session, or my colleagues Anna Hoffman and Buck Woody. I hope you have a great rest of the day.